So, in algebra, we study the quadratic functions or quadratic equations. And the standard form of the quadratic equation is written as ax squared plus bx plus c equals 0. If we were to generalize a quadratic function, would be more likely f of x is equal ax squared plus bx plus c. So when we solve quadratic equations, we set the value of f of x equal to 0. We call those solutions zeros or roots, and we can use different methods to find those solutions, such as factoring, completing the square, or we can also use a quadratic formula. But something has struck me in my mind since I began teaching this, that if, for example, when we get a linear quadratic system where we have a linear function and a quadratic function, when we solve it by graphing, we notice that the solution, if any, for a system of a linear and quadratic function is the 2 points that touch that graph, or the point that touches that graph. So looking at that, if we graph a quadratic function or the quadratic equation, when we look at the zeros and the solution, since we're setting f of x equal to 0, is like a line that is constant, and we are just verifying whether that line touches the graph at 2 points or at 1 point in some cases. So pretty much making that argument, we could say that solving quadratic equations is almost like solving a set of functions, like where one function is equal to a constant. In this case, for most cases where we're looking for the roots or zeros, where the constant of one of the sets is equal to 0, which will be f of x equal to 0, and then the other one would be a quadratic function. But that brings me the question, so can I still find solution under values of f of x? What if f of x is equal to 5? Then if I want to use any of the methods that we normally use, then I will just have to rearrange. I will set f of x equal to 5. So I will set it in there, and then I will subtract, and I will rearrange it so it looks like the standard form of the quadratic equation. We know now that c will be reduced by 5, and I will not be able to call this a 0, but it will still be a solution. And what I'm looking at is, if f of x equals 5, then that means that I'm looking at this particular line that is constant and trying to see if that line crosses or touches the quadratic function. I don't know if this makes sense, but it's something that I've been thinking about it. And to me, it makes sense. To me, it makes sense that you could have a system of equations, and to find solutions to the quadratic function, you will need to set the value of f of x, and that will generate f of x being equal to a constant f of x equal to a constant, say for example d, and that constant has to be d cannot be equal to 0, but it can be equal to something. If it's equal to 0, you get the standard form. So you will get a set. So you can find solutions for sets. If d is equal to 0, is a standard equation, is a standard form of the quadratic equation. So yeah, it's just something that's been bothering me. So when I look at possible solutions, if I have a quadratic function, what I do by setting the f of x, I'm just setting up that particular line where I'm looking interested in seeing, will that line give me a solution? Will that line touch the graph? When it comes to a linear equation, we know that when we look at a solution, if we look at a linear function, f of x is equal x plus whatever plus a constant. That line, when we look at it, when we set up the value of y, what we're looking is that point where the graph, where the line x touches the graph at that point. That's what we're looking for. So like for a linear function, so we have y is equal to x plus, say, plus a. So if we have a graph like this, when we set the value of y, then we can probably solve the equation algebraically. And what we're doing is we're looking at that line, y is equal to that particular, they call it the constant b, that particular line where it touches the graph. So the same way you could say by doing that, if you set the value of f of x different, then you're going to see the value of the quadratic function different, then you're going to get different lines. So that you will check to see if it touches, and it will give you different solutions. For example, if you set up on this one, you may end up with one repeated solution, but if you end up in all the other ones, you end up giving you two solutions. Anyway, again, that's something that I thought about it, and I don't know if I have expressed myself pretty well, but the idea is like solutions to quadratic function at f of x not equal 0 can be obtained by thinking of f of x as a system of equations where one of the equations is f of x equals a constant and the other equation is the quadratic function. Anyway, that's all I have. I don't know what you all think, and give me comments and we'll see if this makes sense or not.